Hi, welcome to online tutorial series on 8051 microcontroller programming and interfacing. For more information, you can visit us at www.jcbrolabs.org. You can also download the source code and web content of this video from that website. So in this lesson, we will talk about the relay interfacing to 8051 microcontroller, and we will also talk about the basic hardware circuit diagram which needs to be implemented for interfacing a relay. So first let's have some theoretical description of the relay. So when we talk about relay, so there are several applications for microcontroller when it is required to control high power appliances or to control high power appliances or AC appliances from this microcontroller. So as we know, this microcontroller works on plus 5 volt, but AC can be from 220 volt or 10 volt, or it could be any other thing. Similarly, it could be DC, high voltage DC like 12 volt or 240 volt. So all these appliances which have high voltage, then those microcontrollers can be connected through this relay. So relay provides isolation between this low voltage device on which microcontroller is working and between high voltage devices. So how this relay works? So let's have a first little introduction of it. So there is a coil in relay, and then at the output there are three connections like this. This is point, and this one, and then this one. So when relay, this is the internal part of the relay, and generally there are 5 pins which are out to the relay. So when no supply is connected to this coil, this particular point is connected to this point. So these points and these points are connected to each other, and as soon as we provide a supply, like depending on the ratings of the relay, like the relay which we are using, those relays have 12 volt rating. That means we need to apply a 12 volt power supply at the input pins of the relay or at this coil in order to energize it. As soon as we apply this plus 12 volt supply, current starts flowing through this coil, and it got magnetized and it attracts this particular switch to here, and this connects to this point. And as soon as we connect this power supply, now these 2 points are connected to each other. So if we have connected a supply like this, or we have connected a LED like this, so now the LED will start glowing as soon as we connect the power supply. And if we remove the power supply, this switch further goes here, and this circuit goes break up, and this LEDs or any other plus sign appliances goes off. So this is the basic circuit diagram for implementing a relay. So now one thing is sure, this is the 12 volt supply which is needed, but the microcontroller gives 5 volt output supply. So we need a driver circuit, as we have discussed while interfacing DC motor. Similarly here too we need a driver circuit which will connect 8051 microcontroller signal, and then which will apply here, and then it will connect to relay to the 8051 microcontroller. So there are several kinds of relays are there. So the relay which we are using, it has 5 pins, and its back diagram is like this. We have one pin here, the other pin here, and the next pin here, and we have 2 pins here. So prior to understand, because the relay can be in different forms, we need to understand which pins are connected to each other. So for this relay, we need to apply this positive voltage at these 2 pins, and normally this pin is connected to this one, and as soon as we apply a power supply here, this pin connects to this particular pin. So for making a circuit, we will connect a power supply here and here. So now let's have a look on the real relay and let's understand how to test relay prior to using it. So this is a relay as we have discussed in theory. It has total 5 pins. Different relays have different kind of structures or different numbers of pins. The basic is from this side, as this may not be visible in this in the video. Some of the ratings of the relays are given, like what should be the DC voltage in order to turn it on, or what are the operating range for this relay. Further, there are several pins for such kind of relay. For other kind of relay, there could be lesser pins. In these 2 pins, we need to provide connections, and some of the other pins we need to provide different circuit which needs to be make on and off. So for that, in order to understand like which pins are connected to where, we check it by through the continuity test from this multimeter. So the continuity test means we set to the this multimeter to the beep sound point, and then when we make a short circuit, it shows a produce a sound. So we check pin one by one and check which pins are connected right now. So if we check these 2 pins, the AND pins, if these are visible. Okay, so there's no sound. And let's check this middle pin as we have discussed in theory. So okay, so right now this middle pin is connected to this one of the corner pins of this this relay. That means this is the connection. This particular pin, this middle pin and this particular pin are connected when no power supply is connected to the relay. That means when no power supply is there, these 2 pins are connected to each other. Now let's check by providing a power supply. So this is a 12 volt relay. 12 volt relay means it requires a 12 volt power supply in order to turn it on. So we have a board here. So we'll connect a 12 volt supply, and listen carefully. You will hear a sound as soon as we connect a 12 volt supply. That's which indicates okay, the connection has been made, or the motor or the relay has turned on. So let's now connect the ground. So you might hear a sound as soon as we connect supply. So this sound indicates that as soon as we have connected a supply, other connections have been made, and this LED and this relay is turned on. So now if we check the continuity from these 2 pins, these are no longer connected, and now this middle pin is connected to this other pin. So if we release this power supply or make the relay turn on, these 2 pins are connected, and as soon as we connect this power supply and it turn on, so these last 2 pins are connected now. So through this easy way you can check which pins are connected and which pins are not, because this particular information is crucial or is needed when we are making a further hardware circuit. So this is the relay. Now let's go towards the programming part and let's understand how to make a circuit and how to make a program for the relay interfacing. So now we have understand how to test relay and how to make it on and off prior to implementing it. Now understand how to connect it with this 8051 microcontroller. So as we just discussed, we need some driver circuit for connecting a relay to this microcontroller. So we used ULN2003 IC. which acts as a driver circuit for connecting this relay to the microcontroller. And there are several other forms as well. We can also use a transistor based circuit as well, but this relay is very handy and it's single IC, so we don't need to worry about any other parameters for this one. So let's first understand, if we talk about transistor based circuit. So for transistor based circuit, you can connect it relay like we have NPN transistor in this format, and this goes to the pin goes to the microcontroller. This is 1K and this is plus 12 volt, and our relay connects here like this, and this is connected to ground. So when 0 is applied there, this relay is on, and when we applied 1 here, this relay becomes off. So from this 0 it is on, from 1 it is off. Similarly, it is very simple, and this transistor used here, it is generally BC547 transistor or BC548 transistor, because this particular series transistor are very commonly used for as a switch applications. Now for ULN2003, let's have a IC data sheet for that. So it is a 18 pin IC, and circuit diagram is very simple. We have 7 input pin and 7 output pin. This 8 is connected to ground, and this pin number can be connected to plus 12 volt. Now we just need to connect this 16 pin number of this IC to one end of the relay. So the circuit diagram is simple. This pin number 1 will go to the microcontroller pin, and this pin 16 will go to the one pin of the relay, and this 8 will connect it to ground. So now let's see how to complete it with the help of 8051 microcontroller. So this will be our circuit diagram which we will be implementing. So we have this 8051 microcontroller, and we have connected this pin 1.0, port 1 pin 0, to the pin 1 of this ULN2003, and this pin number 8 of this ULN2003 is grounded, and then pin number 18, this is pin number 16 of ULN2003. So we are using a relay, so we will make the connections like the relay which we have, and we have connected this to plus 12 volt power supply, and this particular pin, and now we have these two pins. So when the relay is off, these two pins are connected and the relay turns on, this and this is connected. So we have connected a 5 volt supply, and then through this one we have connected a LED here like this one, and the second end of the LED goes here. So you can check the previous diagram which we just discussed. In that diagram we just connected LED in a opposite direction. So this is the correct circuit diagram, and here we have connected a 1 kilo ohm resistance, and this is the plus 5 volt. So this is just for the demonstration purpose. So as soon as we apply 0 here, this LED, this relay will turn on, and just by sending 0 and 1 we can make this LED on or off. So when we press 1 here, it is 0 because it is active low output. If I can see somewhere, it is active low high output, so that means on applying 1 we get 0 at the output. Okay, so as soon as 1 is here, 0, you will get 0 here, and Similarly, like this we can connect it. So now let's write a program for the same. So let's open Keel. Create a new project. In this RELY. And let's connect 89S52. Okay, yes. So let's create a file and let's save it, relay.c, and now add. We can add from here, add files, add, close, and let's change the flash of this output, create hex file and target 12 Hz. Okay, so now let's write program. So first hash include reg52.h, and then let's provide a signature for the delay function. For delay, now because we are using only one single pin to control the relay, so we'll define with the help of this add bit, s bit 1 port 1 pin 0 is equals to bit relay is equals to port 1 0. So define relay void main void. Now let's define this delay function, void delay unsigned entity, and now define unsigned int I comma j, and then two for loops, I equals to 0 to I is less than t to I plus plus, and then another loop for j is equals to 0 to j less than 1275, and then j plus plus. So we'll simply turn on the relay and turn off the relay. So first make an infinite loop, and further again for demonstration purpose, like program is working fine, we will also we also have connected 8 LEDs to the port 2, and we'll send some command for alternate blinking to port 2 as well. So first send like 0x0 AA, and then make relay 1, and then delay of 300, and then P2 is equals to 0x05 0x55, and then relay is equals to 0, and then delay. So as we have discussed, it is active low, so when we are connecting providing 1 to the relay, output is 0, and because the relay other point is connected to 12 volt, we get 0 here, so it will be connected. So this is how we can simply turn on or off our relay. So this is the simplest program. So let's now compile it and see if everything is fine. Yes, so we can also debug it. Let's checking it whether it's working or not. So port 1 and port 2. So it is very easy to interface, to write a program for interfacing a relay. The only thing is this hardware circuit diagram. This got a little complicated sometimes. So it's 1, then it's 0, so it's working perfectly. So let's have a look if we can try. So let's try to make the same on the Proteus. So actually it is a good habit to check perfectly prior to implementing the work on this hardware. So we have 89C51 here, and then we have, let's say, relay. Okay. Okay, so this is the relay. Let's make it this one. Yeah, and let's see if we have ULN 2003. Yes, here. So this pin number 1, and we need to change it like this one. And let's connect here ground. Let's see if it is working. Yep, it is working. But the thing is, when it is +5, it is when this is +1, output is 0. It's fine, but the relay setting is there, so let's make it to 5V relay instead of 12V. Now let's see. Yes, so when 1 is there, it is on, and when 0 is there, it should be off. Okay, so it is permanently connected in simulation, so somehow it is not working properly in simulation. But the thing is, okay, our output, it is fine to see our circuit is working. That means our program is working fine. Okay, now it's working properly. When 1 is there, it is on, otherwise it is off. So now let's have a look on the, now let's burn the program onto this microcontroller, to the processor on this programmer, and then connect it, and then identify the microcontroller. Now it's identified, open X relay, and then upload it. So now once it is uploaded, our programming is done. So let's wait for some time to see whether it is working fine or not. It is nearly done. So programming is done. Now let's see how the hardware is working. So this is programming is done. This is the Arduino board from which we have connected our 8051 microcontroller through SPI interface, and this was used to program this particular 8051 microcontroller. Now further, as for the demonstration purpose, we also have connected these LEDs to port 2, and as we see in the simulation, these LED will blink alternatively. And this pin 1 point from here, pin 1.0, it is going to the ULN2003 IC. So this is ULN2003 IC. So the input to this ULN2003 pin 1 is going from 1.0 of this microcontroller from here. Now the output of this ULN2003 is connected to the relay 1 as we have discussed in the circuit, and 12 volt is connected at one point. Now in order to demonstrate like this LED is this relay is working, we have implemented a small LED circuit on this breadboard, and this is the circuit and this is the LED. If you see, okay, this is glowing, so let's change the direction. Yes, so this was the LED. It is connected through 1 kilo ohm resistance, and one point of this LED is going to the +5 and another end is going to the relay circuit, and then the other end of the relay is connected to the other end of the relay. This one is connected to the ground, so that when relay is on, it creates completes the circuit from plus VCC to ground, and LED turns on. All these circuits are make as per shown as per discussed in the circuit diagram. So as soon as this LED is on, you can hear the sound from this tick sound. LED is turning on, and when relay is off, LED is off. So this is how we can interface this relay to this 8051 microcontroller, and further we can use this relay to power up any other high voltage appliances or AC appliances as well. So for time being, we have just connected this LED here only. So when relay is on, LED is blinking, relay is off, LED is off. So this is how we can implement it. So let's move back to the theory lesson. So we have seen how the hardware is working, and it's working fine. So this is how we can interface relay to the 8051 microcontroller. And one more thing, this was not pin number 18, it is pin number 16, because ULN2003 is of 16 pin only. So I hope you understand how to interface ULN2003 to 8051 microcontroller. So that's it for this video. Thank you.